we're gonna start. I'm gonna present you Pedro Torres. So Pedro Torres is the director of software engineering in Salsify. I tried to get a bio to intro Pedro Torres, but I mean, he worked in so many companies that if I try to enumerate them, we would have no time for the actual talk. I mean, he worked from Farfetch, Bleep, Sonai, Talkdesk, so many companies. Now he's on Salsify. He has 12 plus years of working uh, with the engineering teams, creating them and running them. I mean, I'm for sure excited about this talk. We have so much to learn with Pedro Torres. So I would invite Pedro Torres to join us. Just one thing, if you want to address some questions to Pedro, please do use the slide in the chat. You can find the Slido link. You can go there. You can leave questions, and Pedro for sure will ask them, or if not all, most of them by the end of the talk. Okay, and keep commenting on the chat if you're liking, if you're not. Give us your feedback. Thanks a lot. So Pedro, the stage is yours. Feel free to come in.
Thank you, Rui. Thank you, everyone. Let me share my screen and so that I can actually kind of keep this one going. So hopefully everyone can see my screen by now. Can you see my screen? I'm assuming yes.
Yes, it's perfect. It's perfect,
okay.
Pedro.
Cool. Okay, so let's start. I usually like to start a little bit with Portuguese. So, olá a todos. Obrigado por estarem aqui. Espero que gostem desta talk. Vai ser bocadinho diferente do normal. And now switching back to English. So, hi everyone. Thank you so much for being here. I hope you enjoyed this talk. It's going to be a little bit different from the usual. But nevertheless, I'm expecting for you to have a good time. So today's presentation is called Hara-Kiri from Engineering Best Practices. And this was actually an idea that came up talking with a colleague of mine. His name is Pedro. And we were discussing some subjects, some issues, some practices from engineering that can actually be like very interesting, but also they can actually have a lot of pitfalls. And that's what I'm going to explore here today. So I was already introduced, sorry. So hi, my name is Pedro Torres, or Pedro Torres, if you're not from Portugal. I'm currently director of software engineering at Salsify. So it's actually a new company that I joined the company very recently. And definitely, I would say that probably the highlight of my career is having more than 12 years creating and running engineering teams, giving them autonomy, mastery, and purpose. In case you don't know what Salsify is a company that has its headquarters in Boston and its EMEA office in Lisbon. And pretty much is a company that helps brands win on the digital shelf. So if you want to know a little bit more about that, reach me out at the end and will happily talk to you about the company. So I think it's fair to say that this building trifecta that I'm presenting here today can ruin a company. So maybe it's because, let's say, a company builds the wrong product, okay? Maybe it's because a company actually builds the right product, but at the wrong time, or simply because it just built the product, it just built it the wrong way, regardless of being the right product or the wrong product. And so today we are going to deep dive on the last one, so building it the wrong way. But nevertheless, I would like to shed some light on the first two building problems that you can face, regardless of being a big company or a small company, a startup or so. So building the wrong thing can be probably one of the worst things that can happen to a company. Pretty much because you invested time, effort, knowledge, maybe some of the money that you had available to give it a shot. And at the end of the day, it just didn't went as you expected. Or maybe even if you're a big company, right? You want to launch a product, you have a reputation, a huge customer base, and all of a sudden, no one really cares about that product. And that's problematic and can hurt a company pretty bad. So just for you to have an idea of what types of products that you can see that are completely wrong, I brought you here a product that is actually a very interesting one and quite up to date, at least with the person. It's Trump steaks. So this is actually not a joke. So the product existed, okay, and it was launched in 2007. Do you know how long the product was in the market? 2 months, and they just killed the product. Go figure, right? So this was back in 2007, I'm sure. But as you can see, well, you can actually get really wrong with the product that you created. In this case, some steaks with the future president of the United States. Then you also have another problem, right? It's like you've built the right product, but simply it was not the right time for it, or the market was not ready to consume the product. And that can actually be very hurtful for a company too. So I brought you here an example that it's called Webvan. So I'm pretty sure that if you look to the image on the left, Webvan, you're going to see a truck, right? With what it seems groceries, and you have like here.com. So this is pretty much an online grocery store where you pretty much buy your stuff, and it was delivered to your house. So this in theory is great, right? But this company was founded in 1996, so even before the year 2000, and they went bankrupt 5 years later. As you can see, then on the image on the right, you have Amazon Fresh. And Amazon Fresh is a huge success in the United States. And pretty much it's the exact same product. Actually, it was Amazon that then bought Webvan in 2009, 2007, I don't know exactly the year. And they kind of, recycled the entire concept, kind of, wash up the brand, and then you had Amazon Fresh. So as you can see, the exact same product in the wrong time or in the right time can actually have very different results. And last but not least, the one that we are actually going to talk about today is building it the wrong way. So you can have a product that can be brilliant or not, but if you don't build it in the right way, so with the right engineering practices, you're going to probably ending up like this. So hopefully you've seen some memes about COVID, because it's actually quite trendy right now. So as you can see, we have some ground to cover today. So don't be too stressed, because it's not going to take that long. I'm just going to try to kind of to shed some light on each of these practices or concepts that I really believe that can actually make a difference when you're building a product from success to disaster. So let's start with the first one. So the first one that I brought you here today is regarding tech debt. So tech debt is pretty much the consequence of making a decision, of taking a shortcut, of implementing something a little bit more hacky than, kind of the right approach that probably will take longer, but in the long run, definitely will have benefits. But, sometimes pressure from customers, time to market reasons, a lot of things that can actually make you or force you to make the decision of taking some debt in order so that you could ship faster a bug fix, an improvement, a feature or so. And just for you to have an idea, so tech debt is almost like a monetary debt, okay? So it's something that obviously, if it's not paid regularly, you're going to accumulate interest. So it's going to get bigger and bigger. And the problem with the debt that gets bigger and bigger is that it slows you down, okay? So this is actually a very interesting image. So if you start accumulating tech debt, it means that your teams are moving slower. So you're going to get slower time to market, and that's going to frustrate your customers. So here's the funny thing. Just because having a lot of tech debt means it's not great, so it means that you go slow, so having tech debt seems to be bad, my advice to you regarding this is that you shouldn't fully pay it too, okay? This is pretty much like the house mortgage. So it's something that you take that debt and you start paying it regularly. That's why, tech debt shouldn't be ignored, but you shouldn't kind of stop everything just to kind of to clean the entire debt, because that would mean that for X amount of months, you wouldn't do anything else besides just cleaning this up. maybe like, for instance, Zoom US had something with security and stuff similar to that. So at the end of the day, what's really important is tech debt should be managed. This is the key concept here. Manage your tech debts. Regarding buzz factor. So first buzz factor is a kind of a dark concept, because pretty much is like, it's a measurement where you say, okay, let's think about a given knowledge or an expertise, a skill set. So looking into your team, how many people would need to get hit by a bus in order for you to get into trouble? And although this is being a little bit dark, you know, what we are trying here to understand is, if you have like just one single person that knows about one specific thing or knows how to do a specific task, if that person, it really doesn't need to hit by a bus, but let's say that he goes on vacations, you're going to be in trouble, because for that amount of time, you won't have anyone to do that job or to know that thing. So you really need to watch out and make sure that your buzz factor inside your teams are high and not just one. But here's the interesting thing about the buzz factor. Just because being a low number, it's not good, like 1 or even 2, if it is, let's say, 10 or 15 or even 20, that's not great too. And why? Because if you invest a lot in making sure that everybody knows about everything, that's going to be a huge cost too, and probably is not that worth it. So buzz factor is something that, although never to be one, just don't go crazy about it. Make sure that you find the sweet spot regarding the buzz factor, and that you have some interesting redundancy regarding knowledge and skill sets. So this one here, I think we can all blame to the Spotify model, the model that not even Spotify did. But actually, that's an interesting article that you can read about it. So in case you don't know, so a mission-based team or a squad is a small team, cross-functional, self-organized, that pretty much has end-to-end responsibilities, whether it is creating a product or implementing a feature. And that in theory is brilliant, right? Because it means that the team has like a very broad knowledge, so it can actually do one thing from one end to the other. Also, another very interesting thing is that if we take a look to the Conway's law, you see that having vertical teams, it's very powerful because it reduces dependencies and is not going to screw up on your architecture. So here you see an image where you see kind of 4 vertical teams where you have very different skill sets, and so they are quite autonomous and they don't have a lot of dependencies. So in theory, this is brilliant. Okay, so it's like a sweet idea, let's go for it, but not quite. So although I think that this concept is great, it's really, really hard to work on very complex and deep architectures, because for a single team to go to an existing architecture and do infrastructure work, backend work, front-end work, database or data source work, maybe some sort of caching system or indexing services, it's architectures can be so broad and so complex that imagining that just like 4 or 5 people can do all of that, that's really optimistic. So what I believe here that you should do is combine the vertical with horizontal teams, making sure that the verticality of your teams really take in consideration the depth of your architecture. Make sure that your teams are quite autonomous and with very few dependencies, but not up to a point where you're going to kind of to make sure that everyone needs to do everything, because that won't be effective too. Then another one that I really like is scalable and resilient systems. So this is actually one of my favorite things. I'm really passionate about this subject. So everyone loves like a highly available, scalable, resilient, bulletproof system that never fails and is always up and running for the customers that we love. But one thing that we really need to understand is that offering, let's say, 4 nines, 5 nines of availability, it's really, really hard. If you take a look, for instance, for Amazon and Google, they only promise 99.95% of availability of their services to their customers. And they are Google and Amazon. So you really need to make sure that you make the right investment on this subject. And let's face it, like one huge trend right now, it's Kubernetes. So Kubernetes is a project that was created by Google, and that pretty much a lot of companies are migrating into. and they are struggling a lot with that because working with Kubernetes is really hard. For instance, Salsify, we're actually doing a great job, but it's not easy. It's really not easy, and I've seen a lot of companies struggling with this. Also, for instance, bear in mind that as soon as you want, and sorry for the image being a little bit small, but this is like quite big, the image, but because companies are working so hard and paying so much attention to scalable and resilient systems, if you want actually to kind of to provide a world-class service where you have like a huge uptime, take a look to what it takes, right? So it's like having multiple availability zones, having multiple regions, having lots of services, the front end, the back end, redundancy, data stores, disks with disk replica. So it's not easy. It takes a lot of effort, and effort it's usually translated into money, right? It's time. It's an investment. So you really need to make sure that you should bet on this area to a point that is actually profitable. So don't try to just kind of go crazy and try to solve the problems on just one go, right? Can say, okay, so I want to make sure that my service works for the entire world, because probably that's not your customer base, or it's not now your customer base, not yet. Make sure that you actually have your services completely dimensioned for your reality and for the near future. And then as soon as you grow your customer base, you're kind of, looking after the resiliency, availability, scalability, observability of your systems. Don't try to kind of solve everything at once because it's not going to be worth it. Another interesting subject is regarding code coverage. So code coverage pretty much means that is kind of the way that you can cover your code, making sure that it's working on the expected behavior. So you created some tests that are kind of verifying that the code that you just wrote, that you are putting in front of your customers, it's working as expected. And it's interesting that on this subject, code coverage, the good practice, or one of the trends that you see in the industry, is to aim to have around 80% of coverage. And you can ask yourself, but why 80% and not 100? Um, to be honest with you, 100% code coverage is fine. So it's actually possible. But the question here is, why are you aiming for 100% code coverage? What are you trying to solve with that? Because one thing that it's really important for you to understand is that just because you have 100% code coverage, it doesn't mean that you are bug free. Software is always going to have bugs. Hopefully all of them really minor subtleties that usually have interesting workarounds to solve them, or to kind of to cope with them. But hitting 100% code coverage with the false hope that you will never run into bugs, that's simply not true. Because remember, even your tests might be poorly written and they are kind of verifying something the wrong way. So bear in mind that although this is a great metric to keep track of, 100% code coverage will never assure you that you won't have any sort of bugs. This is probably my favorite one. So for the people that know me, I have a very strong Agile background. I've actually been an Agile coach, a Scrum Master in some past lives. And after, so the Agile Manifesto was written in around the beginning of the 90s. So, after like 30 years or so, we are still talking about Agile. Obviously now more than ever, and yes, Agile frameworks are very, very popular, from Scrum to Kanban, Lean, probably some of them a little bit more complex, like Safe and Less and everything Nexus. So stuff that kind of tries to scale the Agile frameworks. But the funny thing is that at the very end of the day, the majority of the companies, they simply decided to adopt software. There is Atlassian and Jira that we all know, right? So here is a Jira board that we all know and love. And sometimes companies actually believe that just because they are using Jira, they are already being agile or doing agile, or just because they have, user stories or sprints, that they already find a way to do agile. But the important thing here is that, being or doing agile, it's not about following a process. It's not about kind of following Scrum or using a software for its worth. Being completely honest, Agile is not something that you should strive to get to, because Agile is not a place. And what I'm kind of inviting you here for today is actually let's stop about talking about Agile, and let's start talking about agility. Because what's important is not Agile, it's agility, the agility of teams, the agility of companies. And so agility, in my opinion, it's the ability to quickly gather and act upon feedback, because that's what matters, right? It's how easy can you incorporate feedback, like a surprise, something that happens in the outside of your company, let's say COVID. How can you cope to that? How can you react? Are you fast enough to send your people home so that they don't get sick and you can still actually have your business running? Because that's not being agile, that's agility. It's kind of being able to act quickly and upon some feedback, being from your customers, being from external factors, you name it. So this is what is important about agility, not being agile. Another one that is interesting is Yagni. So it sounds a little bit funny, but Yagni means you're not going to need it. So it was a principle that was brought by extreme programming. So this is quite old, but nevertheless really up to date, which usually means that someone actually, instead of kind of just coding what is supposed to be done, so let's say ship that feature, is actually goes way beyond that. And so when you do that, you're pretty much gold plating, which means that you're kind of overdoing stuff. And what the Agni tells you is you don't need to do that. Just do what is enough so that stuff works. Don't try to solve problems that you're not facing today. But what you usually see is like engineers say, "Oh yes, but someday this or this might happen." But that's just doing assumptions, And I've seen a movie that says that assumption is a mother of a very interesting thing. So use Yagni all the time. Think carefully the problems that you're solving, and make sure that when you're putting some effort, you're solving that problem just enough so that you can actually continue and fulfill the needs of your customers. Don't gold plate stuff. Here in this image, for instance, you can actually, so this is a funny one. So the application, what the user wants is that saddle, and it has, an engine. And yes, they got a little bit excited and then just went above and beyond with the engine. And as you can see, maybe it's like an engine from an aircraft. So as you can see here is a very interesting example that, I don't know, like maybe one day they would actually need this engine, but who knows? They don't even know if the app is going to be accepted by customers. So why put that sort of effort? So that's what the Agni tells you. Is like, don't assume stuff, know what you know, solve the problems that you know, and just continue making sure that you don't try to solve problems that don't even exist or are being brought to you. So it's really easy to, to fall into the trap of adopting like stuff that is completely overkill, because, it's fun to solve complex stuff. But never forget that simple and elegant solutions are usually much harder to do, and they are much more effective. So this syndrome, I've witnessed it a couple of times. It's called the not invented here syndrome. And, long story short, it's pretty much a tendency to reinvent the wheel. So let's say, it's kind of the assumption or the belief, that you have some product outside that probably it's to address your use case or the problem that you're facing, but you believe that if you develop in-house, you're going to be much better at it and you're going to address your use case much better. And yes, that's true. Even it's just because, let's say, the IKEA effect, I don't know if you know it, it's pretty much a bias, which, engineers or the people, the builders, place a huge value on the stuff they are creating. And if you think a little bit IKEA and assembling the furniture, you'll see that you love the furniture that you bought from IKEA, not because of, the quality of the furniture for sure, pretty much because you're probably going to spend like the entire afternoon of a weekend building the furniture or assembling the furniture. And so you're going to love it anyway. So the not invented here syndrome is more or less explained because of that. And so, yes, we are bright engineers, very, very intelligent, top of the class. And so we believe that we usually can do much better than what exists out there. But, it's really easy to find flaws in other solutions. So I can actually take a look to hundreds of softwares and solutions and systems and say, oh, this won't work because of A or because of B or because of C. But one thing that you really need to understand is that if you go for an existing solution that suits your use case, regardless of being an open source of a software as a service, you're going to be much faster to market. So this sort of adoption, so going for an existing solution accelerates time to market drastically instead of investing, let's say, 6 months, 3 months, if maybe a year, inventing something or building or solving a problem that other companies already did, right? And for instance, if we talk about open source, you have entire communities supporting it. Or even if you go for a SaaS solution, you have a company with tons of engineers that are already working actively on that. So why should you go out of your core to do something that is almost like not the thing that you need the most, right? It's like it's not vital to you. It's stuff that helps you on your solutions, but it's not what you're selling for sure. So make sure that you invest the time on the right things. Then you have microservices. So microservices, if you search online, it's like a huge trend. Everyone's adopting them, and pretty much all companies usually start with a monolith. So it's like a single app, quite big, where it does everything for everyone. Okay, and usually that's what a startup does. But nowadays, you actually have a trend where you have like multiple services that are loosely coupled and doing the exact same work, but working much more isolated. Here in this image, for instance, you can see the monolith on the left and the microservices on the right. And although I love a microservice architecture, maybe not micro, but a service-oriented architecture, um, the monolithic approach, it's much easier. You have a lot of things, a lot of problems, a lot of efforts that you have on the right that simply they don't surface in the beginning, but they can easily get you into trouble. Like for instance, imagine yourself running hundreds of microservices. You would fall into a maintenance nightmare. So remember that loosely coupled servers are great when you actually need to scale. But if you're just kind of starting a product and you don't even know if you have market fit, if it is the right product, don't put that sort of effort. Start with a monolith, like all successful startups do, and then understand if you need to kind of to migrate to a microservice architecture. Don't start with microservices right off the bat because it's not worth it. Then you have multiple languages in your stack. So this is actually an interesting one. So because of microservices, the one that we just spoke of, because you have like several services that are isolated, that are working by themselves, communicating with RESTful APIs or stuff like that, you can actually have very different code bases. And because you have different code bases, you can have different languages. So while in the monolith, you would be locked to one single coding language, so the language that you're actually going to build your product. In microservices, you have this sort of freedom, so it gets you unlock to take a look to different languages. And for instance, what I brought you here today, it's pretty much like 2 handfuls of languages. And I just brought you like open source one, like free one, so you don't need to pay for them. So you have like JVM languages like Groovy and Scala and Java. You have Ruby. You have Go that is backed by Google, Kotlin, Python, actually is one of their experiments. You have JavaScript. So you have tons of languages that you can actually choose from. But the problem here is, as soon as you start opening up let's say the menu of the languages that you want to adopt and running in production, let's say that you're running stuff in Ruby, then in Python, and in Go, you already have like 3 languages in production. This pretty much means that the teams that are working with these languages, they are going to kind of to put themselves in a silo, because let's say the team that is working in Go don't understand a lot about Ruby, so they won't be able to help the Ruby team, and vice versa. And the guys from Ruby probably won't be able to help a lot the team that is working on Go. And so the question that I ask here is, why should we adopt so many different languages, like if it would almost like be a zoo? It doesn't make a lot of sense, and it has a lot of costs hidden. So my belief is that choosing a language to code with shouldn't be a lighthearted decision, shouldn't be even like a team level decision. It really needs to be kind of, a department, engineering group decision, because it brings a lot of consequences. And the funny thing is that I barely seen a problem that was solved by a specific coding language that usually is not actually solvable by the redesign of an architecture. So very few problems can be solved because you're using coding language A instead of B. So be mindful when you want to introduce a new coding language in your organization, because it usually takes a lot of effort and it has a lot of hidden costs behind them. Then legacy. So, legacy is something that it sounds old, sounds boring, and yeah, no, it doesn't sound fun or exciting to be honest, right? But here's the thing, right? If you have legacy in your company, it's because you made it that far. You didn't went bankrupt. You didn't close. So legacy is actually something that should be welcomed. It's like, great, we actually have something that we can actually look. It's history. It's something that you should be proud of. But the funny thing is, at the moment that you call a system legacy, the legacy system, no engineer will want to work on it. And why? Because it's not challenging. It's boring. We like greenfield projects, bleeding edge technology. So don't get into the trap of calling legacy to any of your systems, because you're going to have a lot of trouble here. Yes, just like this image, right? So it's a dinosaur. No one would love to work on that. But here's the interesting part. The code that you write today, tomorrow will be legacy. And it will be your code anyway. So legacy shouldn't be a problem at all. And actually, there's a famous sentence that says, legacy is usually what pays our salaries, because legacy is existing stuff, is the stuff that our customers use. And that's why you have a successful company. The things that you're kind of brand new working on today, they are not making any sort of money. They will do in the future when you put it in front of the customers. But probably when you do that, there will be legacy anyway too. So legacy should be embraced and should not be a bad thing or have a negative connotation. We have just two more to go. So pull requests. So today we see a very strong culture of pull requests. Pretty much every company, that ones that kind of building software the right way, they are using pull requests on their day-to-day flows. And pull requests, for the ones that don't know, is pretty much you have the project, you create a branch, so a version of that project on your local machine, you do some changes, and then you submit those changes to be reviewed by your peers or so. And if you get some thumbs up, then you can actually incorporate the changes into the project. So this is actually great, right? Because this image actually explains this quite well. So you have like the master branch, which is the main line, or the trunk or main. You create a branch, you do the changes. Someone else is going to review your code. It's going to give you like a thumbs up saying, hey, it looks good to me. And then you can actually put back your changes into the main production line. And as you can see from this image, pull requests are great because you're actually going to have a different pair of eyes looking into your work, which is good, right? If you made a mistake or you're introducing a bug, the other person is actually going to cut it, hopefully. So pull requests are great guardrails. They are perfect. But never forget that you're actually adding a next step on your working flow. So in theory, it's getting you a little bit slower, because instead of just kind of merging stuff directly into your code, you actually need for someone to review it so that you can actually put the code in. Also very interesting is that enables feedback and knowledge sharing, because if I'm doing a task by myself and then I open the pull request, more people will take a look at it, I'll receive feedback, they will learn what I'm doing, and in theory, everything is great. But this is only worth it, this sort of investment of going a little bit slow on your flow because of this, if it actually is being taken seriously, and the people that are reviewing your pull request and giving you comment, they're actually kind of taking a serious look at what they are seeing. Because if people are just kind of giving you a thumbs up saying, hey, it's fine, then you're just wasting your time, because you're pretty much kind of ignoring everything positive that pull request would be there to offer you. Last but not least, the one that probably is the most unclear one is deploying code on a Friday. So what's the problem with deploying code on the Friday? Okay, so imagine yourself, it's a Friday, probably in the middle of the afternoon, maybe in the morning, and you have 2 days of weekend in front of you, maybe more if you have a national holiday. So the question is, should you deploy stuff? Should you introduce a variable of uncertainty in your production systems in front of your customers, or should you just be a little bit more cautious and say, no, I'll wait till Monday to deploy it? And the truth is, you have strong opinions weekly held, two very different school of thought. So you have the school of thought that says there is any problem at all, so you should just ship stuff on the Friday like if it was a regular day. And you also have, the school of thought that says, well, pretty much in this image, it was very well represented. Should I deploy on a Friday at 5 p.m.? No. What if I just no? So, like, you shouldn't do it. It's like this is the message here on this image. But my thought on this is, it's perfectly okay to be risk averse. Well, everyone can be risk averse. It's human, and that will pretty much mean that you will avoid deploying code on certain occasions, before weekends, before a national audit day. Maybe it's because of a code freeze of a Black Friday or a Cyber Monday or something like that, or things, Christmas, specific times. But I think that you shouldn't invest your time and your energy on discussing if you should deploy on a Friday or not. What you should actually invest your energy in is in striving to deploy at any moment, hopefully multiple times a day. Deploying code into production should be almost like, after coding should be the thing that you do more frequently. Because if you can't do this or you're afraid of doing this, that doesn't say a lot of good things about the confidence of your code or the confidence of your process of shipping stuff. So, and that's where you actually should put your energy in, not discussing if you should deploy it on a given day or not. So we are pretty much in the end. This was pretty much everything that we discussed. We covered a lot of ground, so I'm pretty sure it was actually a lot of to take in. But definitely, I hope that I kind of brought you some light on stuff that maybe to sound like a no-brainer, but has some subtleties and some pitfalls that you really need to watch out for. So if it would be only one thing that I would ask from you today, would be to think to yourself after everything that you saw here, are you building your product the right way? Thank you.
Thank you, Pedro. First of all, great presentation. I guess we all took from here lots of insightful information that I don't know if there are some product team leads here in the chat, but they will probably use on their teams, if not product engineering teams, wherever. Some very insightful information. Do you mind if I make you some questions that some people left here?
Sure, absolutely.
Okay, so the first one is, how did you build your track record? Passing by so many companies, what were the tricks to build solid foundations that usually require several years?
Wow. So that's a personal one. It's an interesting one. So I'm going to be honest. So one factor here definitely is luck. You really need to be on the right time at the right moment with the right set of people. So definitely, I think I was lucky or blessed. It really depends on your beliefs. But it takes a lot of effort to be lucky too. So I think that the way that I kind of created my track record was pretty much a combination of a lot of effort. So, a lot of nights that I just invested on myself, reading books, um, perfecting my craft instead of just watching Netflix and stuff like that. So yes, it takes some effort and some personal sacrifices. Doesn't mean that you won't be able to have fun, because obviously you can have fun, but you really need to make sure that you grab the wheel of your career and you make the right investments instead of just hoping for someone to actually to provide that for you. Um, and then kind of make the right investments. For instance, I discovered Agile in 2010, and that was one of the things that kind of marked my career for sure. Working in London also opened up a lot of doors and opened up my horizons and way of thinking. And then make sure that you choose the right companies to work with. I don't have any doubt that if I wouldn't be working in companies like Salsify, where I can actually have access to what people are doing in the United States and different ways of thinking, different cultures and everything, I would not be so well succeeded. So you just need to make sure that you put safe, strong bets, and don't be risk averse. Just go out there and do your best.
Great advice, Pedro. So another question here is there a metric that you think it's essential to use in engineering teams? A metric?
Yes. So I have some of them for sure. One that I value a lot is definitely the lead time. So the moment you start working on something, how long does it take to actually to end up in production? it should be just days. It should be very, very short. It shouldn't be like take forever. If you're working on something, it takes you months to get accomplished. That's usually a smell. So make sure that you work in small batches of work, that you ship regular to production. Don't wait, let's say, weeks or months to do that. You should release as often as possible, and that usually translate into healthy teams, happy teams, because no one likes to work for something that is just kept in the drawer. So make sure that your teams have the ability to ship regularly and they can actually receive regular feedback. So that's usually around this sort of thing that I try to measure stuff. Because at the end of the day, I believe that metrics should be consumed by the team to understand how the team can actually be better at what they are doing than anything else.
Okay, I agree. João Ayres also in the first talk talked a bit about metrics. If you want to check, you can go there. So another question, how do you manage the multiple language situation you described with your engineers' desire to innovate and try new things?
So that's a good one. So I think there is always a place for innovation. I struggle a little bit with the idea that you're innovating just because you grab a different language. Again, I think that you usually innovate because you have different products. You innovate because you grab different architectures or even technologies. The language by itself, I believe it's probably the least of the things that you can actually innovate with, because again, coding something in language A or B shouldn't be like the huge difference in terms of innovation. Nevertheless, I believe that you have hackathons to do that. You have POCs, small experiments, maybe a system that is not relevant or not critical mission for you, so that you can actually kind of play a little bit with that. Because remember, although I'm completely in favor of innovation, if you end up in production with a zoo, what I usually call a zoo of languages, let's say with 5 or 6 or 7, that's going to bring you a lot of problems, right? Let's say the team with language A has a very specific problem. They are working in a silo because no one else knows about that stuff. How can the other rest of the team can actually of the engineering group can help out? So you're going to find a lot of problems. So yes, innovate, but there are some decisions that really need to be very well thought. And at the very end of the day, if you want to put some crazy stuff in production because you want to experiment, just make sure that it's not critical, that it's well built, that you can slowly send traffic there, and you have like all those measures, making sure that you can actually minimize the risk of doing something like that.
Great,
Guardrails, pretty much.
great answer, Pedro. So another one is, how do you feel about resource pools with interchangeable developers as opposed to fixed dev teams?
So I have a very strong opinion about this. So I like fixed teams. I don't like interchangeable pools or whatever you want to call it, because I believe that teams are not just the sum, of each individual. It has much more beyond that. So together we are stronger than we are like just individually together. What I want to say with this is each team creates its own dynamics. Okay, so one guy like in the 50s, Bruce Tuckman, wrote actually about the 4 stages of a team, and that actually only on the last stage of a team the team is actually performing, so high performing teams. So if you're constantly changing the people that are working together, you will never get to a point where you actually find a high performing team. So don't believe that myself working with someone else or with a completely different person that we are going to have the same sort of dynamic. We are not kind of making shoes here. We are doing something that actually takes a lot of science. It takes a lot of dynamics, and communication and collaboration. It's almost like a football team. Every time you change something, the team changes, and it really needs to work again to reach its peak. So don't mess a lot with teams unless obviously someone wants to change the team by its own will, and then it's fine. You really need to accommodate that somehow. But kind of, just pulling people in and out of teams like if they were resources is something that I really am against.
Yes, I couldn't agree more with you. Yeah, for sure. In my situation, I completely agree with you. A team is very important yeah, to build a
Absolutely.
foundation.
Teams are the unit, not
Yeah,
individual.
exactly, exactly. I completely agree. So we are just stepping on time. Just time for one final question, okay?
Sure.
Pedro? So, don't you think the main problem with a too strict vertical organization is the non-reusability while teams should try to use existing solutions?
Come again, I really didn't
Yeah,
understand it
sorry.
correctly.
Don't you think the main problem with a too strict vertical organization is the non-reusable while teams should try to use existing solutions?
So yes, a little bit. I think that for you to be successful in adopting like very vertical teams is for the other systems, let's say, because so today like the technology stack is very deep or broad. So you need infrastructure, front end, you need back end, so very different skill set. So the only or the way that I see vertical teams working the best is if, for instance, let's say regarding infrastructure, if you have already in-house services that are providing you everything that you need without having or requiring you to have a very deep knowledge about that very specific skill set, you know, and kind of almost having a lot of things as a service, let's say infrastructure as a service, having a platform as a service, having backend or systems as a service and things like that, that you can actually just kind of call them and use them and create a product. I think that that's kind of okay in the sense that you have a lot of things that are for free and easy to use. Because if you don't have anything of that and you expect for 5 or 6 engineers to do everything from one end to the other, it's not that it's impossible, but it's going to take a lot of effort, and you want to make sure that everyone's useful. And let's say if I solve all the infrastructure problems and then I'm just with my arms crossed waiting for someone to solve the front end problems, there is not going to be a motivation for me. So you really need to make sure that these full stack teams, vertical teams, they have everything they need. So the tools as a service in order for them to fulfill their jobs. I agree.
Well, thanks a lot, Pedro. There was a couple of questions that we could not answer, but please feel free to reach Pedro,
Sure,
and
absolutely.
I'm sure he will answer all your doubts.